Geometry lesson 6-4. Continuing our work with parallelograms and dealing with some special parallelograms, we're going to look a little bit more closely at some other shapes and how they relate to parallelograms. So for starters, we're going to look at a rhombus and the corollary to a rhombus. The rhombus is a parallelogram that's going to have 4 congruent sides. That's the only thing that matters in order to make it a rhombus. 4 congruent sides. So here we have 4 sides that are all the same shape. Now, they don't always have to look in this way. It doesn't have to look like a square that's been tilted over. It could be a square. A square, in fact, is a rhombus. A square is a rhombus because squares have all 4 sides that are the same. The key is you have to have all the sides. It has nothing to do with angles. So the corollary, what we can pick up off that, is that a quadrilateral, 4-sided shape, is a rhombus if and only if it has 4 congruent sides. The angles don't matter. 2 congruent sides doesn't matter. It can only be a rhombus if it has 4 equal sides, 4 congruent sides. That's the key. And then looking at more the angles perspective for parallelograms, we have the rectangle. The rectangle now doesn't take into consideration the lengths at all. In order to be a rectangle, you simply have to have 4 90-degree angles, which means by definition of a rectangle, a square is in fact a rectangle because it has 4 90-degree angles. So the corollary is that a quadrilateral, 4-sided shape, is a rectangle if and only if, so I've just taken this right here, if and only if it has 4 right angles. The only thing that matters to making it a rectangle is that all 4 angles are 90 degrees. All right? But if you can take those and put them together, that's how you form the square. So it's taking both the concepts of a rhombus and a rectangle, combining them for one. So again, a parallelogram with 4 congruent sides and 4 congruent angles. This is only going to be a quadrilateral if and only if it satisfies both the requirements of rhombus and rectangle. It has to be both. And that's what makes a square. And then dealing with some special situations, all right, these are some theorems for the diagonals of these parallelograms. A parallelogram is a rhombus. Okay? Parallelogram is a rhombus if and only if its diagonals are perpendicular. So, say we were to label this as all the sides being the same, that means it's a rhombus because all 4 sides are congruent. And the diagonals are now crossing, we would know they're crossing at 90 degrees. There is no other way around it. Now if it's not a rhombus, so the lengths are longer, then these diagonals will not cross each other at 90 degrees. The only way they're going to cross at 90 is if all 4 sides of the rhombus are the same. Simply being a parallelogram is not going to make them cross at 90. But if it is a rhombus, they will be at 90. Alright? Another theorem is that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So, if this truly is a rhombus, which again means these sides are all the same, then what will happen is these 2 will be the same angle, these 2 will be the same angle. These will be the same angle, and these will be the same angle. So they will bisect, but only if it's a rhombus. If it's not a rhombus, then it will not do any bisecting, only if it's a rhombus. And the last special circumstance, a parallelogram is a rectangle if and only if its diagonals are congruent. So if it truly is a rectangle, I should probably get rid of this shape. If it truly is a rectangle, then what will happen is this diagonal will be exactly the same distance as this diagonal. So if I were to label it A, B, C, D, we would say that AC is congruent to BD. So this is the same as this. And we already know that they bisect, so we know that they're all actually, each segment is the same, which would tell you a lot about the triangles themselves. Alright, so those are some more pieces to the game of parallelograms and some of the special relationships therein.